Localization of function refers to the principle that specific functions, like language, memory, interpreting senses, don't just occur all over the brain. Instead, there are specific structures in the brain which are specialized to carry out a certain task. This idea has been supported by recent neuroimaging studies, but was also examined much earlier, typically using case studies. One such case study is that of Phineas Gage, who in 1848, while working on a rail line, experienced a drastic accident in which a piece of iron went through his skull, destroying much of his left frontal lobe. Although Gage survived this ordeal, he did experience a change in personality. He is often reported as having permanently lost his inhibitions, so that he started to behave inappropriately in social situations. Some reports state he became violent and uncontrollable. This change provided evidence to support the theory of localization of brain function, as it was believed that the area the iron stake damaged, the frontal lobe, was responsible for personality. However, it is difficult to generalize case study findings of those with brain damage to the rest of the population. There are 4 key areas that you need to be aware of: motor, somatosensory, visual and auditory areas. You also need to know about the language centers. Visual centers. A nerve impulse from the retina is transmitted via the optic nerve to the thalamus, which relays it to the visual cortex in the occipital lobe. Input from the right-hand side of the visual field transfers to the visual cortex in the left hemisphere and vice versa. Auditory centers. Nerve impulses from the cochlea in the inner ear travel via the auditory nerve to the brain stem for decoding, then continues via the thalamus to the auditory cortex, where the sound is interpreted. Input from the right ear is processed in the auditory cortex in the left hemisphere and vice versa. The motor cortex. The motor cortex is found in the frontal lobe and is responsible for voluntary movements. The motor cortex sends nerve impulses to the muscles on the opposite side of the body. The somatosensory cortex. This is located in the parietal lobe. It receives incoming sensory information from the skin to produce sensations related to pressure, pain, temperature. Robertson, 1995, found that this area of the brain is highly adaptable, with Braille readers having larger areas in the somatosensory area for their fingertips compared to normal-sighted participants. The language areas. The Broca's area is named after Paul Broca, who discovered this region while treating a patient named Leborn, who was more commonly referred to as Tan. Tan could understand spoken language but was unable to produce any coherent words, and could only say Tan. Broca's area is found in the posterior part of the frontal lobe of the left hemisphere, near to the motor region, which controls the mouth and vocal cords, is involved in speech production. People with damage to this area experience Broca's aphasia, which results in slow and inarticulate speech, however they can understand language. Carl Wernicke discovered another area of the brain that was involved in understanding language. Wernicke found that patients with lesions to Wernicke's area were still able to speak, but were unable to comprehend language. Wernicke's area is found in the left temporal lobe, and it is thought to be involved in language processing and comprehension, recognizing language and associating it with meaning. People with damage to this area struggle to comprehend language, often producing sentences that are fluent, but meaningless. Wernicke's aphasia. Evaluation. Although there is evidence from case studies to support the function of Broca's area and Wernicke's area, more recent research has provided contradictory evidence. Dronkers, 2007, conducted an MRI scan on Tan's brain, to try to confirm Broca's findings. Although there was a lesion found in Broca's area, they also found evidence to suggest other areas may have contributed to the failure in speech production. These results suggest that Broca's area may not be the only region responsible for speech production, and the deficits found in patients with Broca's aphasia could be the result of damage to other neighboring regions. Furthermore, psychologists suggest that it is more important to investigate how the brain areas communicate with each other, rather than focusing on specific brain regions. Wernicke claimed that although the different areas of the brain are independent, they must interact with each other in order to function. An example to demonstrate this is a man who lost his ability to read, following damage to the connection between the visual cortex and the Wernicke's area, which was reported by Dejerin. This suggests that interactions between different areas produce complex behaviors such as language. Therefore, damage to the connection between any 2 points can result in impairments that resemble damage to the localized brain region associated with that specific function. This reduces the credibility of the localization theory and also case studies, as it's often difficult to know whether the part of the brain damaged in a case study patient is just a relay station. There are also gender differences. Women possess larger Broca's and Wernicke's areas than men, which is presumably as a result of women's greater use of language. This suggests a level of beta bias in the theory. The differences between men and women are ignored.